In calculus, a function is one of the most essential and foundational ideas because it provides the framework for describing how quantities depend on one another and how they change. A function is essentially a special type of relation that associates every element in a given set, called the domain, with exactly one element in another set, called the codomain. The output values are known as the range, which is a subset of the codomain. For example, if we define a function, the input can be any real number, and the function will produce one corresponding output, which is the square of that number. What makes functions important in calculus is not only the way they map inputs to outputs but also how they allow us to analyze patterns of change. Calculus is often described as the mathematics of change, and functions act as the tools through which this change is measured and understood. The concept of the limit builds upon functions by examining their behavior as inputs approach specific values. This leads to the study of continuity, where a function is continuous if small changes in the input produce small changes in the output without sudden jumps or breaks. The derivative, another central concept of calculus, represents the instantaneous rate of change of a function at any given point. For example, if models the position of a moving object, then its derivative gives the velocity, showing how quickly the position changes with respect to time. Similarly, higher-order derivatives can describe acceleration or even more complex rates of change. On the other hand, the integral of a function represents accumulation or the total effect of continuously varying quantities. For instance, integrating a velocity function gives the total displacement of an object over a period of time. Graphically, a function can be represented as a curve on the Cartesian plane, where the horizontal axis represents the input variable and the vertical axis represents the output. The shape of this curve provides insights into the behavior of the function, such as whether it is increasing, decreasing, concave up, concave down, or approaching an asymptote. Functions can also be classified into different types, such as polynomial, rational, exponential, logarithmic, and trigonometric, each of which has distinct properties and applications. In real life, functions are used to model countless natural and human-made phenomena, from population growth, motion of planets, and spread of diseases to economic trends, business profits, and engineering designs. Without the concept of a function, calculus would lack the language needed to describe and solve problems related to change, making it the cornerstone of mathematical analysis.